Hello, my dear students. Hope all are doing well. This is again Mithun Raj, your science master from Kerala, Kochi, and this is the second video for 9th standard class. Especially it is our same chapter. It is matter in our surroundings. So, the last video we just discussed about something about this matter, which is around our surroundings. So, mostly we are studying about the properties of these matters. Last class we studied that matter mostly in modern science. The basic existence of matter is in three states: solid, liquid, or gas. Okay, but the other properties of matter also, it includes like plasma and two or three others we will discuss it later, but first we can go through these three. So in last class we already studied that matter is anything which occupies space and has a mass. For example, me, I am also a matter. I am occupying this much space, so I am also a matter here. Okay, my dear kids, then let us start. So yesterday we studied about the physical nature of matters. Isn't it? Physical nature of matters. There was at least four or five of them, I think. Let's just revise it. Matter is made up of particles. The particles of matter are very tiny. The particles of matter have space between them. The particles of matter are continuously moving inside that matter. You believe that? Yesterday I told an example. Even inside a metal, a big metal bar of iron, lots of particles are moving here and there. Can you believe that? Anyway, we can come with the example. Okay, the first example is it is made up of particles. So mostly in textbook there is a lots of examples for this. Okay, so the first example is a very simple one. Matter is made up of particles. Particles means small granules, small part of matter. A simple example, just take a glass of water and add some sugar into that. Stir it well. Before stirring with a spoon, just look. We can see tiny particles of, small particles of sugar inside that, mostly deposited at the bottom. But after we stir it, what will happen? That sugar is disappeared, isn't it? That small particles of sugar get dissolved in small particles of water and they are mixing with each other. So there is no trace of sugar in that water. So that is a proof that matters are made up of small particles. What happened in that experiment? Tiny particles from sugar dissolved in water and it mixed with the small molecules of water. So it disappeared. So that is a proof for matter is made up of particles. Next one was all these particles, even though the particles are small, again it is made by very tiny particles. Even the sugar particles are small, isn't it? If we powder it, it will become again smaller. Even though the particles are small, that particle is made up of very small particles. We can see another example for this. For example, if we are taking a jar of water, okay, a jar of, or a cup of water, and if we are putting, you heard about potassium permanganate? Or leave it, you can use common ink. Understand? You will get this ink in your stationery shop. Buy a small bottle of ink and put few drops of ink into that water. What happens? For example, I am using here red ink. So the entire water will change into red in color. Any doubts? No doubt about that, no doubt. It's a common example. Take another cup of water, pure water, and take 3 or 4 drops, these colored drops, and put it in the next water. What will happen? The color of that water also changes, isn't it? Again take few drops from the second glass and put it in the third glass. What will happen to the third glass? There also the color of the water changes. So after that, just observe these 3 glasses. Just observe it. What? Any difference will be there? Will the color of the 3 glasses will be same? or different? Anyway, the color will be same, it will be red, but the first glass will be dark red. The second one a bit more light, and the third one a bit more light. And if we are continuing this till the fifth glass, we will get the last glass as more lighter. That means tiny particles from the first glass, it moved to the next one and the next one and the next one. What we can understand by that? Because the water molecules or these particles are very, very tiny, isn't it? Just imagine if you are putting marbles. You know what is a marble? A piece of marble. 10 marbles if you are put into first glass, and from that we are taking some water and putting into the second. Any color changes occurs? No, because the marbles are bigger, isn't it? It won't dissolve. But in the case of this ink, it already dissolved in that water, and when we are shifting the water into different glasses at the same time, that small particles are tiny particles are shifting from one glass to another, which proves that these particles are made up of very tiny building blocks called as the atom. So the next one is about these particles have space between them. Understand? Like this. For example, this is a case of liquid. These particles have space. So this is a diagrammatic representation of solid, liquid and gas. Just see. Solid mostly it will be like this. These particles are closely packed. Okay, it will be very closely packed. But in the case of liquid, it will have some gap. In the case of air, lots of gas is there, isn't it? Lots of gas. So what is the example for this? Again we can use the same example of sugar or salt. Take 1 liter of water and add 100 grams of sugar into it or salt into it. Dissolve it. What will happen? The sugar or the salt particles will again dissolve in that water. But if we check the level of that water, if we check the water level, any difference will happen there? No, there won't be any difference, because these water molecules or these sugar molecules or salt molecules, they are not making any change in the physical state of water. What they are doing? They will just go in between these water molecules. Understand? Like this. They are not getting accumulated at the bottom, neither get accumulated at the top. What happens to these small particles of sugar or salt? It will spread in between these spaces which the water molecules have. So that is a proof for particles of matter have space between them. So the next physical properties of matter was about particles of matter are continuously moving. Particles of matter are continuously moving. Let's see an example for that. At a good morning time, you are sitting in the drawing room and watching movie, and suddenly some smell comes from the kitchen. Your mother is making something special for you. Okay, just imagine something like gobi Manchurian or whatever food you want. That smell from the kitchen, it passes the dining room, it passes the dressing room, and it came to the drawing room you are sitting, where you are watching the movie. At least like 20 meters from the kitchen to the drawing room. How is it possible? If this particle does not move, will that smell will come from kitchen to this room? No. What is there happening there? That fragrance, that particles which brings that fragrance to that curry, that fragrance will spread through the air as water vapor. And these water vapor particles carries that fragrance particle also. So it will spread through the air. And from the kitchen it reached the tip of our nose. At that time we are getting that sensation of that smell. Isn't it interesting? So that's a proof for what? That is a proof for the particles of matter are continuously moving. And another thing is that the particles of matter are, they will attract each other. A good proof, last class I think we discussed about this, a nail, a chalk and a rubber band. Three different types of solid. Chalk, you know, you have seen that in school. Nail, everywhere, wherever you just see, you can see a nail. Here also I have one, but I cannot take it because it is already plunged into the wall. So the next one, a rubber band. What is the difference between all these things? Anyway, all three are solids, but their properties is different. So particles of matter attract each other. If that particle does not attract each other, will it become a solid mass? This pen I have in my hand, it looks like this. You know that it is made up of millions of particles, but it looks like a cylindrical pen. Why? Because the particles inside this pen, they attract to each other. That's why it has a shape, isn't it? But in the case of nail, chalk and rubber, which solid will be easier for us to break? Of course the chalk, isn't it? So from that what we can understand? In chalk, the attraction power of particles are very, very low. But in the case of rubber band, it is a bit more than the chalk. And in the case of iron nail, it is maximum. Understand? So then tell me, which material will have more attracting power? I will give two examples. One is glass, the next one is diamond. Which matter has more attracting power? A diamond or a glass? Okay, this is a question. The answer you can post in that WhatsApp number. Okay, see this video, find the answer and post it in that WhatsApp number. The question is, among these two matters, which has more attracting force? Is it diamond or is it glass? Interesting question, isn't it? Okay, fine. So there are the 5 different physical states or physical properties of matter. Then we can briefly move to the 3 states of matter: solid, liquid and gas. And what all properties does they exhibit? So now we are going to study about properties of first one, solid. You know these 3 are different forms of matter: liquid, gas and solid. But why we are saying it in different names? Because their properties are different. Understand? First we can take solid. For example, tell not a rock. A rock is a solid, isn't it? So what are the properties of a rock? What happens if I throw you with a rock? Of course you will get hurt. Why? Because it is very hard. So what is the first properties of solids? Solids have definite shapes and fixed volumes. So whatever solid we will take, it will have a definite shape. For example, this pen. It has a definite shape, isn't it? If it is in the liquid form, can I hold it like this? No, it will flow down. So solids have a definite shape and fixed volume, isn't it? What do you mean by volume? The amount of space occupied by that particular matter is called as volume. So this will also have a particular volume. It won't change. It's very difficult to change the volume of this solids because it is very hard and it must has a definite shape. Another example for solid is this one. It has a particular shape or not. Every time it is not changing its shape. This board, this pin, this paper and all, it has a particular shape and volume. Every solids. Next property of solid is space between the particle is minimum. Come here, let's see this. See, if we zoom into a solid, okay, a piece of rock with a microscope. What type of microscope? not ordinary microscope. If we want to see solid particles or these atoms and molecules, what type of microscope we want to use? Of course, it is an electron microscope. If we are zooming in to a solid, a piece of solid, with an electron microscope, we can see small particles like this. Understand? And they are very near to each other. Okay, very near to each other. That means the attraction force is high in solids. And the space between, if the attraction force is high, normally what will happen to this space? It will be less, isn't it? Of course it will be less. From this diagram itself we can see that gases attractant force is very low, liquid it's medium, and for solids it is very high. This thing is, I just draw it a bit more bigger so that you can understand. Actually this is the real diagram, this zoomed diagram of this. This one is about solid, okay? This one is about solids. So that is the second property of solid. So these particles are, space between the particles are very minimum in solids. The next one is the force of attraction between the particles is maximum. It's a common thing. If the space is very less, means attraction is very high. Attraction of particles inside a matter is inversely proportional to the space between them. If space increases, attraction decreases. If space decreases, attraction increases. Is that clear? Next one is the movement of particle is minimum. You can see that it is highly congested here. Isn't it? Highly congested. So it is very difficult to move in between these particles. For example, just imagine a market with full of crowd. Understand? A full of crowd. We want to move from one part of the market to the end of the market. Is it easy for us? Because the crowd is totally packed together. So when we move, we will hit here and there. And better in this corona time, don't go to a market, okay, where there is a crowd, okay. Don't tell that the teacher told, go to market for the experiment. That's why you are running away to the market. No, don't do that. It's only an example, okay. So if the force of attraction is high, the space between each particle will be very less. So it is very difficult for the particles to move inside the metals, but not metals, solids. But some particles are moving inside. You will study that in later chapters. So that's the third property. The next one is the movement of particles is they are least compressible. What do you mean by compress? Compressing something. If I blow up a balloon, okay, blow full, I will blow a balloon and I will tie the end and I will give you. Can you squeeze it? If you squeeze that, what is happening inside? The air inside that balloon is getting compressed, isn't it? The same time, have you used that, what do you say for that big syringe called pitchkari, I think, during Holi and all? Isn't it? You are squeezing out the water. When we push the handle inside of that squeezer, what will happen? The water is, with force it is going outside. Why? Because the water gets compressed inside the cylinder, isn't it? So, but in the case of solid, just imagine, instead of water, how you put that color into that pitchkari. I don't know the correct name of pitchkari in Kannada, but I think we can call it as a squeezer, okay, squeezer, or a big syringe. With that squeezer, you are squeezing. What will happen? The water will compress and it will go out with a force. Just imagine if you are putting only that color powder. You are not putting water inside that cylinder. Will that go outside? Now, the powder is solid, isn't it? So, it is very difficult to compress. If you want to move that water outside that pump, we need to add water into that. So, it becomes liquid and liquid is easy to compress. So, these solids are very difficult to compress. At the same time, this one, understand? Is it easy? I put my maximum power, but still, I hurt my hand. But still, the pen looks like the same. So, it is very difficult to compress the solid. So, the last property of solid is their rate of diffusion is least. What do you mean by diffusion? Moving from one place to another. In the case of this squeezer, what is diffusion means? When the pressure increases, it will releases outside very fast. Okay, that's called as diffusion. So rate of, if the compression is very less, the diffusion rate will be also very less. So these are the properties of solids. I will give you written notes about these properties of solid, liquid and gas. It is a 3-mark question, mostly 3-mark question, and one of the most important part in this chapter. Okay, not only in this chapter, you must, as a science students, in future also you must know these things. Understand? This is a common thing a science student must know. Properties of solid, properties of liquid and properties of gas. Okay. Let me see. Next one is properties of liquid. Understand? Mostly we can combine these 3 properties, solid, liquid and gas. If one we are studying, properties of solid we study means automatically we will get the answer of gas. It will be almost opposite of the solid. And liquid means it is in the middle between solid and gas. In the case of liquid, okay, we will do one thing. We will go for gas. All opposite of solid. First one, this does not have any fixed shape or volume. See, here and there it is moving here and there. Any fixed shape? No, each and every time the gas is moving here and there. There is no particular shape for it. In some place we cannot even see that. In some cases we can see. For example, smoke. The smoke coming out of a fire. You can see that, isn't it? It has a particular shape. No, each and every time it is changing its shape. And it has a particular volume. No, there is no constant volume for that. That's also changing every time. Can you look to a smoke and tell what shape it is? No, because it is changing every time. Just opposite of the solid. The next one is the space between the particle is maximum. Isn't it? The space, is it maximum or not? Here see, minimum. Just opposite to the solid. So the next one comes as the force of attraction between the particle is what? For gas, maximum or minimum? Force of attraction is minimum. That's why this much gap is there. Just opposite to the solid. Next one, the movement of particles are maximum. Lots of space is there. Just imagine you are going from market, okay, from this side to that side, and nobody is there. Isn't it? You can move wherever you want. You can move here, you can move here, wherever. You can dance and go, isn't it? Am I right or not? So you are free to do whatever things while walking through an empty market. And in that case, only few people are there. Oh, this one is a mango seller, this one is a pumpkin seller, this one is a whatever seller. Only few people are there. So, as you wish, you can move here and there. The same thing about gases. These particles can move freely. Wherever they want, they can move. Okay, one more is, they are the most compressible. It is very easy to compress gas, isn't it? It's very easy. It's very easy to compress gas. Just, for example, how many volumes of air is filled inside a bike tire or a cycle tire? If the air is in the atmosphere, it will be like an entire air in this room. That entire air we can compress inside that cycle tube. That's why it becomes very stiff, isn't it? So that air inside is highly compressed inside that cycle tube. Okay? So it is very easy for the air to compress. Just opposite to the solid. In the case of solid, we cannot compress it, but in the case of gas, we can compress it to the maximum. The next one is the rate of diffusion is more than solids and liquid. The diffusion rate is very high in liquids, isn't it? Diffusion rate is very high in, no, I'm sorry, not in liquid, it's in gas. The diffusion rate is more than solid in liquid, but it is maximum in the case of a gas. About this diffusion, some application level questions is been asked in the previous years. So this diffusion we will study in another class. Okay, we need some extra details for that. Okay, so the next one is about the liquid. Let's see. Liquids also does not have any particular shape. Okay, the water flowing through the river or a stream, does it have any particular shape? I cannot see any particular shape, isn't it? If it is moving through a cylinder, not a, sorry, if the water is flowing straightly and if there is a rock there, what will happen? The shape of the water will change, and after hitting the rock it will circle it, and again it will forms the previous shape, isn't it? There is no particular shape for the movement of this liquid. Okay, next one is space between particles is intermediate. It is medium. It is not like solid. It is not like gas. It is intermediate, medium. Understand? Not that much distance like gas. Not as much close as the solid, isn't it? So the next we will go for the force of attraction between the particle is also intermediate. I told solid just opposite is gas and liquid is in the middle. Understand? In the middle. Liquid comes in the middle. Understand? Yes. All the properties are same. All the properties are same. If you are able to study the properties of solid, you can study the properties of gas and also the properties of liquid. Okay? Gas opposite, liquid in medium. The movement of particle is also intermediate. See? Particles moves because some space is there. This is like a market with 50% of the people. Understand? In the case there is full crowded people, so it will take you 10 minutes. But at the same, it is 50% crowd means it will take you only 5 minutes to move here to there. And if there is very less people, it will take you 0 minutes, correct? Now it will still take some time because you need to travel from one place to another. Okay, leave it. And this water are also, they are compressible. Water is more compressible than solid and less compressible than gas. You understand what you mean by compressing something? Just putting pressure and making it smaller. Understood? For example, in the case of a cycle pump, isn't it? We are compressing the air so that it is getting inside that rubber tube of our tire, isn't it? So, liquid is more compressible than solid and less compressible than gas. And the rate of diffusion also is same. The rate of diffusion in liquid is more than that of solid and less than that of gas. So basically 60% or 70% of the chapter is over, and this thing is important, properties of solid, liquid and gas, and definitions for matter and 3 different types of matter, solid, liquid and gas. That's the more important things we will study in this part. And the next is about evaporation and all. You studied evaporation in 6th standard, isn't it? I think you studied about that. That means the change of state. Evaporation means the change of state. Where is my... I kept something here. Next we will study about the change of state. Evaporation is about change of state. It's a simple clue I will give. Ice, water, gas. Change of state, isn't it? How it is occurred. Just find the answer. 3 options are there. Not options, these clues. Ice becomes water, becomes gas. Again, gas becomes water, becomes ice. Just go through the video and find me the answer. How ice will become water and how water will become gas, and how gas means water vapor, how water vapor will become back to water and the water will become the ice. So find out the answer and just type it in 1 sentence or 2 sentences and post it in the group. So tomorrow we will study about evaporation and diffusion in detail. So for now I think it is enough for today. So that question I asked, try to give the answer. What was the question? 2 matter which has more force of attraction. Diamond, option A diamond, option B glass. Just type the option in the chat, otherwise give the name. Diamond or glass, diamond or glass. Think. Okay. Anyway, this is Mithun Raj signing off from this part. One more time I am telling you about this is a bad situation, which is the corona time. So be safe, stay at home, eat good food, good water and whatever things your parents say, listen that and do exactly like that. See you kids in the next session of this class. This is Midun signing off. Thank you. Jai Hind, my kids.